This is again day 2 of our notes on chapter 7. In section 5, we're going to write formulas for geometric sequences in both their explicit and recursive forms. Starting with the explicit formula at the top, what we can do is we can find the explicit formula knowing the first term and the ratio. As with before in our arithmetic section, we would multiply by the ratio to get from one term to the next term, from the first term throughout all of the other patterns. Something I'd like to show you, maybe with our first exercise, is how we can do this. We are given our first term, but not given our ratio. Remember last page, or the last section, we would take any term and divide it by its previous, and we would get our ratio. So in order for me to get from one term to this term, the first term to, let's say, the fourth term, let's notice something. I would multiply by the ratio once, twice, 3 times. From the first term to the fourth term, I'm multiplying by the ratio 3 times, or 4 take away 1, or cubed. So this formula seems to make sense. To get to the nth term, we'd multiply by the ratio n minus 1 times. To underscore this, if I wanted to get to the second term, I'd multiply by the ratio to the first. If I wanted to start with the first term and get to the third term, I'd multiply by the ratio times itself, or ratio squared, and so on and so forth. Let's go ahead and write this explicit formula. One more time, notice I'm using g's to differentiate my formula for geometric instead of an arithmetic. So I'm going to go ahead and write the general formula one more time. The first term times the ratio to the exponent n minus 1. The value of my first term was 1/4, or 0.25. We'll use the decimal. Our ratio is positive 4, and I'm going to raise this to the n minus first. This is fine. This is simplified. This formula works for integers. N is greater than or equal to 1. We can use this to find any term in the sequence. Specifically, if we wanted to find the 8th term, g sub 8 equals the value of our first term times our ratio, 8 minus 1. So if I plug an 8 here, I plug an 8 here, and I would raise it to the 7th. What I'm going to do is take out the calculator that I had out in the previous section. It still has all those values. I'm going to clear it, type 0.25, multiply it by the ratio to the 7th power, because I did simplify my exponent before I plugged it in. Gets an answer of 4,096. So g sub 8, the value of our 8th term in our geometric sequence, is 4,096. Go across to question 2. Question 2, again, we know this is geometric because the directions tell us to. Our ratio, you take any term and divide it by the previous, so 9 divided by 27, that's 1/3, so it's 3/9 or 1/3. Okay, that last one kind of gives it away. Our ratio is 1/3. Let's write our formula for our explicit. Alright, g sub n equals g sub 1 times our ratio to the exponent n minus 1. Okay, what we're going to do is find the value of our 6th term. To get from the first term to the 6th term, I'd multiply by the ratio 5 times. Okay, now I can sort of try to do this in my head. 1/3 to the 5th power is a power of 3, and 27 is a power of 3. This takes me back to those logarithm days that we used to learn about. So this is 3 to the negative 1st to the 5th. So together this combination gives me 3 to the negative 5th. When I multiply by 3 to the 3rd, I get 3 to the negative 2nd, or 1/9. Let's just see what the calculator would have given us anyway if we use that. Clear it. Our value of our first term, our ratio. Now I don't want to round this. I'm going to use the fraction 1/3. I'm going to raise this to, let's see, we were trying to find the 6th power, so I want to raise this to the 5th. Because it's always 1 less than the term, and I get this repeating decimal. Just a reminder, to convert your decimal into a fraction, hit the math button and enter twice, and it gives me the 1/9. It's kind of hard to read, but there's the 1/9 that I thought about. That kind of is a little bit easier than using my powers of 3, but it's neat when you notice something and you can do it for yourself. The next 2 exercises, now again, we know this is geometric. I'm just going to slide this up a little bit. We notice that this is geometric. We want to find a 7th term. So Any term can be found by taking the first term and multiplying it by the ratio n minus 1 times. Let's see, 3 divided by 2 is just 1.5. I can, of course, use a fraction or a decimal. It doesn't matter which one. But this would be the explicit formula. Something I forgot to do last time. I forgot to write for integers n is greater than or equal to 1, because this formula only works for integer values that are 1 or more. Okay. Next, we're going to find the value of the 7th geometric term. So starting with the first term, I'd multiply by the ratio 7 minus 1 times, or 6 times. Take out that calculator. Clear it again. 2 times 1.5. Close the parenthesis, raise this to the 6th power. Alright, now I got this whole number. I definitely don't want to round this. I'm going to use the whole decimal, or I can convert it into a fraction, which I believe it says 729 over 32. It's good to be exact. 729 divided by 32, and this is the value of the 7th term in that geometric sequence. This last one, why don't you pause the video and try to figure it out for yourself. Now that you've unpaused, what you can do is, again, find your ratio first. In this exercise, our ratio is, forgot to do it the last time, our ratio is negative 1/10. You can, of course, use a decimal, negative 0.1, that works as well. The value of any term can be found using our first term, which is 1,000, multiplying it by our ratio, n minus 1 times. This formula only works for integer values of n that are greater than or equal to 1, like 1, 2, 3, or 4. Take out our calculator. We're getting ready to find our 10th term. So we're going to multiply 1,000, our first term, by our ratio, negative 1/10 as a decimal. Because I'm trying to find the 10th term, I'm going to multiply the ratio to the 9th power, 1 less than the term number. Let's type in a 9 and hit enter. I get negative 1e negative 6, which is a number in scientific notation. I'm going to take my decimal place, which is behind this one, and slide it 6 places to the left. So here we go. 1, 2, 3, 4, 5 zeros, and then a 1 here. Because it's negative, I put a negative in front. What is that as a fraction? Oh, it didn't give it to me as a fraction, did it? It is this answer as a fraction. So if your calculator doesn't convert it, a neat trick we can do is remember your place values. Here's your decimal point, your units, your tenths, hundredths, thousandths, 10,000ths, 100,000ths, and 1 millionth. This is negative 1 over 1 million. And that's how you can convert it as a fraction. Alright, at the very bottom of the screen, or the bottom of this packet, we have the recursive formula for a geometric sequence. Works sort of the same way as arithmetic. We're going to write the same 2 lines, the value of your first term, and then since it's geometric, we're not adding a common difference, we're multiplying by a ratio. I've seen some people write the ratio in front of their previous term, but just remember, the g sub n minus 1 is just shorthand for the previous term, and g sub n just means next term. Or any term can be found by taking the ratio and multiplying it by the previous term. So when I get set up to do this at the bottom, just remember that this formula only works for integer values n is greater than or equal to 2 because there is no previous term before the first term. At the very bottom, what we're going to do is I'm going to draw my bracket because I need 2 statements and set it up just like we've set up every other one. I think what I might do is I might put my ratio in front like it is a coefficient. I'm going to start with my first line. The first value, the value of our first term is 27. Now, I would find the ratio by taking any number and dividing it by the previous number. So 18 over 27 reduces. 9 goes in twice and 3 times. I believe that's 2/3. So I'm going to do 2/3 times the previous term. And again, this formula works for integer values n is greater than or equal to 2. There it is, a very nice recursive formula for this sequence. For question 2, we're going to write our recursive formula. Again, set this up the same way. Our ratio, because the direction says find the common ratio, last time it was 2/3. This time our ratio is 33 over 11, or just 3. The first line, you put the value of your first term. The second line, we're going to multiply the ratio times the previous term, which is always g sub n minus 1, for integers n greater than or equal to 2. This will work. Go ahead and pause the video and try the others at the bottom. The first term is -1. Our ratio is -2. Now, unlike exponential growth and decay, a ratio can be negative in a geometric sequence. We're going to multiply -2 our ratio times the previous term to get to the next one for integers n is greater than or equal to 2. Last one, the value of our first term and the value of our nth term. The value of our first term equals 8. Our ratio is any term divided by the previous. We're going to use 2 over 8 or 1 over 4. It's 1/4 times the value of the previous, and this will work for integers n is greater than or equal to 2. Tonight's assignment is in Delta Math. It is a lot of small 1 or 2 or 3 question sections that is a mixture of geometric sequences and arithmetic sequences, a mixture of explicit forms and recursive forms where you are finding specific terms or writing equations for each sequence. So please log into Delta Math and complete that assignment. Since the videos were very short today and only 2 sections, I did give you a lot of practice and a lot of different types of practice. Best of luck, and as always, please feel free to email me if you have any questions. Have a good day.